All right, hello everyone. Thanks for turning up for my talk now on the Eclipse SDV project. Or I would like to take you on a journey on how to take this SDV, software-defined vehicle stack, to actually do some kind of rapid prototyping in the vehicle. And first of all, I'm kind of glad to see so many faces in this session, considering it's the last one of the day before dinner. And also, I'm also quite happy to see a lot of new faces compared to yesterday's community day, because many parts of this presentation will be somehow repetition of what was shown yesterday in the community day. So consider this more like as a short abstract of the activities in the software-defined vehicle group, which have also been presented at the community day. So what I want to do in the next couple of minutes is to take you on a journey of answering the question, how do I actually get the data out of my vehicle? So consider the case we have any standard vehicle on the street, and we have a wiper, and we really want to see, like for the window wiper, we want to know what kind of data, what kind of intensity do we have in here, and we want to propagate this information to the cloud. Sounds fairly simple. Question is how to do it, how to do this question mark, how to fill it. There's so many options, and one option is what I would like to present in the next couple of minutes about the SDV project. Just to put it more as in a text, let's develop an application which predicts the wear of a windshield wiper just based on its usage intensity. So, how to do that? So the first thing is actually defining the data. So how do we actually talk about the data, what we want to process here? So the solution I would propose in our case is the so-called VSS, or Vehicle Signal Specification. So what VSS is in the end, it's standardized by the CoVESA Association. It's a taxonomy of how to address different data or signals within a vehicle. So as you can see, it's quite straightforward. It's a tree structure. So you start by the root cause node, for instance, the vehicle. And then if you want to know the tire pressure, you just follow chassis, axle, row 2, wheel, tire, and then you go to the pressure. In the same fashion, you also can have actuators in your vehicle. For instance, you can change the performance mode by just setting vehicle, drivetrain, transmission, performance mode. So once we have this out of the way, the question is, what is the right data model or the right data point in our specific scenario for our application? And here, another application or another tool is quite handy, which is Digital Auto. In the end, Digital Auto is, if I say just, they might maybe not so happy, but I would say it's just a website, which is one of its possibilities, offers you the whole catalog of these VSS signals. So you can just search for it, you can just scroll through it, and I just took the work for you because I found there's an actuator, vehicle, body, windshield, front, wiping intensity. So this is exactly the value that we're looking for. So with consuming this kind of data, or this data value, we now get to the intensity. What Digital Auto also offers, besides actually finding your specific value in this whole tree, which is quite complex, it also allows you some kind of prototyping. So that's nothing I will showcase here, but it's an opportunity. As you can see on the top, there's prototypes. So you have like a really basic car simulator there. You can write some basic code, and you can also test out how it would work out. So this is like really the more testing, playing around. But we want to actually have some kind of prototype. So the next thing that we need to do is to develop an application. So how do I do this? The answer for this, at least in the Eclipse SDV space, is Eclipse Velocitas. And I mean, maybe you're familiar with this classic DevOps circle or 8. And Velocitas is trying to support you in this whole journey of actually bootstrapping your application, of getting it in your development flow, and also of putting it into operations. So that's why Velocitas is providing you a lot of different things, starting by a template for your vehicle application. So just a template where you can just start coding. In this case, it's Python. You also have your vehicle app programming model and an abstraction layer, which in the end is this based on, or can be based on this VSS, which I just shown before. So you can here make the connection between this signal that we found in the Digital Auto to then develop our application against the signal. But it's not just about coding, it's also about building and delivering things. So Velocitas is providing you with GitHub Actions workflows to actually test all your applications and also to release them as kind of or not as kind, but as Docker containers. And with this, you're also able to deploy them to your scenario, see what worked, what does not work, and just continue the whole circle again by developing a new version of your application. Maybe so much about the theory. Let's look into some screenshot what it means in practice, because when you develop your own Velocitas app, what you can do is there's a template repository, vehicle app Python template, and what you would just do is create your personal fork out of that. So I did it here with test app. Afterwards, I could do some coding. I will come to that in a second, and do an initial commit, and automatically all this testing infrastructure is set up to run within GitHub Actions. So you can already see how it works out. So next thing then, I just mentioned this, you also have this release pipeline, so you just have another GitHub action. If you trigger that, the result of this will be that you get some containers, be it Linux, AMD64, or also ARM64 containers, which are then available in GitHub packages. So the whole toolchain which you would require to actually come to this container is abstracted away from you, because Velocitas is already providing at least the templates for that. What I skipped a bit is the actual development. And this, I mean, it's another screenshot. I know it's a bit hard to read, but the idea is more, okay, there is a screenshot of VS Code. So, and what this is actually about is, this tiny detail is quite important. Because what Velocitas is doing, it provides for you a so-called dev container. So it's a normal, whatever normal is, Docker container, which has the whole development infrastructure in there. So it has a number of Docker containers, which at least Velocitas also assumes to be available on the vehicle. So you can develop against this application, let's say, model or environment. And with a number of tasks within VS Code and setting up your own code, like your own Python application, you can just get started by just writing a couple of lines of code to have your full application. Then just press 2 buttons in GitHub and you have the container available. All right. So you might now ask, okay, I have this really fancy signal, or in this case also I get the speed over this tree structure, or we wanted to talk about the Viper intensity. It's nice to have an application, but this is just a Docker container. Where is the data actually coming from if I have it here? Because I can run Docker containers on my laptop, but this is not a car, obviously. So with that, let's get a bit more theory here. How these different things in standardization and VSS align. Because, as I said earlier, we have the Kuksa.val alliance, which comes up with the VSS signals, which we also develop against in our Velocitas app. So we have here the VSS structure. And now there's another project, which is also now part of Eclipse SDV, which is the Kuksa project, or more precisely the Kuksa.val project, which is a sub-repository standing for Vehicle Abstraction Layer. And this Vehicle Abstraction Layer is essentially also what this VSS is doing. It provides you an abstraction of your actually deeply embedded vehicle signals. Another thing which is quite interesting to notice here is there's also a cooperation between this Kuksa alliance and the W3C, because the VSS model so far is mainly a data model. So there's no real notion or agreement on how to access this data. So one way could be this SDK, which I have just shown you in Velocitas. Another way could be a W3C API based on WebSockets, which strongly recommends to use VSS. So this way you can see there's a slightly difference between the actual data model and the APIs on how to access this. And there's another nice thing about Kuksa.val, because it actually implements this standard API. But it also has other ways to access this data model, for instance, over gRPC. Maybe as a summary to what I just said, another picture, because this is a situation which is maybe a bit similar to what I've shown in the very first slide. So with a bit more concrete topics. Because again, we have our really deeply embedded world. We have like maybe some CAN interfaces, some IP, whatever you can find in a car, you name it. And on the other side, you have your actual applications being in the vehicle, or you also maybe in the cloud. So the question is how to combine these two. And again, the answer could be this Kuksa.val, or namely the Kuksa.val data broker. Because here, you have the data coming out of this deeply embedded world, which is then transformed or converted into VSS, and then the other applications on top of that can just use VSS and also develop against this VSS abstraction instead of really dealing around with this deeply embedded control units. If you're a fan more of technical drawings, this is the same what I just said, maybe with less graphical notion, but more lines, but it's again the same topic. We have the different ECUs. We have different ways on how to connect these ECUs, be it CAN or some IP, and all of these then connect to Kuksa.val, which the so-called Kuksa feeders, which then communicate or translate between the ECUs or VCU world and this Kuksa.val world. Maybe a short advertisement about the features. So one way to see this Kuksa.val abstraction layer, which maybe also helps you to understand what it actually does, is to call it a so-called in-vehicle twin. So to have a digital representation of your actual state in your vehicle, which obviously also makes it possible to transfer this to the cloud. The implementation itself is quite lightweight, so it's either written in C++ or for the data broker it's Rust. And it's at the moment does not provide any historic data. It's really just the current state in your vehicle, so your applications can develop against the current state. So to limit on purpose here. I mentioned already earlier that we have these different interfaces to interface with that, being VIS, like the standard from the W3C, or more commonly used the gRPC interface. All right. So one notion I really like to make here, also to give you another understanding of why Kuksa.val is so essential in this topic, is to think in terms of data, information, and knowledge. Because here on this very low level, we really talk about bits, or like CAN matrices, or you see some hex dump here. So it's just data. I mean, data is important, but you need to make some sense out of this data. And one way to make sense of this, out of this data is to provide some mapping to these Kuksa.val feeders, which then translates this really information, this data into information, like this data point actually means the vehicle speed, and this is now the information I have. Putting it one layer above, you also can create some kind of knowledge out of this information, because you have it in your tree structure and your taxonomy of VSS, which also takes these different values into perspective or in relation to each other, allowing you to even more complex applications. Because now you know, okay, this tire is actually tire pressure, or this windshield intensity actually is for the front wiper and not the back wiper, stuff like that. Okay. So where are we now? So initially I wanted to put this slide way earlier in the presentation, but I think it did not make any sense before, because there are actually two things to see here. One is the summary of what this velociter is doing, and the other one is what Kuksa is doing. And this also summarizes the whole development flow that you would have with such a velocitors and Kuksa application. Because what you have here is more as a starting point. You have your vehicle model, which is used, which relies on the SDKs, also provided by velocitors, and is also used by your actual vehicle application, which comes as a template. But this template, I mean, template can mean a lot of different things. So the question is, what does this template include in here? And in this case, it's about this test infrastructure that I've shown, this dev container. So remember this VS Code screenshot. It's also about the CI release workflows, and also about you have an actual skeleton for your application. But again, now we have a container, still a container, or maybe two containers. How to actually get them to the vehicle or to the car, because we really want to get our application into the field. I'm not saying production, but at least into the field. So the answer is, how do I actually deploy my container? And as always, in IT, there are a lot of different options depending on your circumstances. You might consider to do a K3S on your vehicle or your on your hardware, to have like a single node Kubernetes cluster in there, which has maybe some drawbacks. You might consider to do Podman or Containerd there, which is also perfectly fine. But then you really have to deal with like a specific node, or maybe SSH into that hardware. Or that's what I would like to talk a bit more in the next couple of minutes. It's you use Eclipse Canto here to manage your edge and also your containers in the edge, where a vehicle could be one example of such an edge. Because what EclipseCon is doing, and this is again more the marketing slide, I hope I can extract the essential information for you here, is it allows you to actually execute and manage these containers in the edge. So the way it is done is you have this edge management here, which you can control over a CLI on the node, but this is maybe not so fun if you really want to manage a larger fleet of devices. But you also have this connection to a cloud. So there's one container or one application running here, the so-called cloud connector, which allows you to connect your Canto instance with one of the clouds. So initially it was with Hono and Ditto and Hawkbit, which are some projects in the Eclipse IoT working group. I will explain it in a second. You could also, of course, connect it to the IoT suite, which is based on these open source projects, and there was also the plan to connect it to the Azure IoT Hub. But the detail here is more that you have this local MQTT broker, so every application, every container which is running here can communicate with this local MQTT broker or Mosquito broker, and then this information can be automatically transferred to a cloud instance over through this cloud connector, which is quite nice if you really want to transport your data into the cloud. So again, our windshield intensity can just be communicated to this Mosquito broker then, and it automatically or magically, there's no magic in computer science, but at least abstraction, is sent to the cloud. But what you can then do, if you have this connection established to the cloud, you can also send messages back to the Canto node, for instance, to the edge management. In this way, you can control the execution of containers from your cloud perspective. So as a developer doing this whole rapid prototyping overall stack, you install Canto on your device, and then you simply send a message to an endpoint in the cloud, be it against Eclipse Ditto, and this is then automatically transferred to Canto and starts the container. So the container starts in the matter of one HTTP call. This is the takeaway here. Use Canto to start your container, and you don't need to connect you to your device directly. More as an example, this is how it could look like in an example which we also have on a booth, which is down the hall. So you have a Linux OS, you have Canto on top of that OS, and you have containers. In this case, one container who is adapting between this OBD and VSS, then transferring the data to Kuksa.val. And from there, you have the Ditto adapter to actually send the data into the cloud. So again, now we have a container, but you already can see there's still a missing piece because there's some grayish Linux OS that comes from somewhere. So where do I get that from? There are many options. So if you go to the colleagues down the hall, they would talk about Debian-based systems and apparatus. Another option, which is done in the Eclipse SDV working group, which is also an approach, is to use Eclipse Leda. Because what Leda is, and I think I'm not a big fan of large quotes, but here I really like the scope statement, so I printed it here. So it provides a system image or kind of recipes to deliver a functional Linux-based image in the context of SDV by pulling together the individual contributions from SDV and the larger OSS committee. There's a lot to process here, because essentially this means we take all the different components we have in SDV, or the Eclipse project, so Canto, Kuksa.val, Velocitas, which I just talked about, and combine them with some other open source tooling, for instance, the Octo project when it comes to Linux tooling. And the result of this equation is Leda. So this is kind of the takeaway you can take here. If you prefer another base image, go ahead. The beauty of Leda here is that many of these parts already come pre-integrated that you would require for your application to actually run. But still, now you have your OS. How do I actually bring this to the vehicle? Like, I have all my software stack, but I have my physical car down there. So there's kind of a mismatch still. And one answer, it's something that I brought here. It's the so-called Eclipse Canopy. I have it in a small version here, or in a very large version here, whatever you prefer. So what it is, first and foremost, it's an open source hardware. So the schematics are open source as part of the Kuksa project. So you can just download it and print it and tinker it if you're really good at putting this together. It's quite a challenge, to be honest. And once you've done that, you can put a Raspberry Pi 4 compute module, so just like this small chip on top of here, on there, and you have a whole OBD dongle that you can plug into any vehicle and execute this whole stack that I just presented there. And this is essentially how you could use this kind of hardware. So to put it up together, we had this question mark, now we have a solution. Because we can, instead of having a question mark, we can have this hardware. On this hardware, we can run a Leda base image. So take our Linux build with Leda. In Leda, we can have a Canto pre-installed or install Canto. Deploy a couple of containers, so this adapter adapting between OBD and VSS. Storing the data in Kuksa.val. Having our Velocitas app to actually consume the data from Kuksa.val. Then this Velocitas app is doing some processing, like whatever you would like to do, and then publish this result to the local MQTT broker, which is connected to the cloud connector, which in turn transfers it to the cloud. And this is the way how to actually transfer this data from a really deeply embedded vehicle and interpret this value so that it's also possible to execute it or have it in the cloud. One thing which is also nice, so far I only talked about the data here, is that you can actually do some rapid prototyping with the Velocitas app, because you can simply deploy and adapt it using the automation that you have available in GitHub Actions. So with this Velocitas framework and all the other components, you are able to realize this or many other use cases that you might come up in a vehicle. And with that, I'm really glad that you're all still here and looking forward to your questions, if there are any.
So how you secure the communication between the cloud and the applications itself, because you're using a very MQTT broker, and so it's inherently directly communication without any cryptography or anything?
I mean, it depends a bit on how you do this communication between the cloud connector and the cloud app.
Yep.
So MQTT could be the easiest option. So if you use TLS and stuff like that you have also available for MQTT, that would be my initial answer. But you could also imagine that you actually have like a really, let's say, more secure link between the cloud and the vehicle. But this is, I would say it's really specific to what you want to achieve. One way which I haven't talked about so much here is that you could also use other projects, for instance Eclipse Hono, to also do the whole communication between the application, which also comes with a set of more features to secure this communication or to enable this communication. So since the scope is more about rapid prototyping, you might really be able to find a lot of different, like for every error you could start the argument, okay, how to make it more secure, what about safety relevance when you're talking about Vipers. So this is at the moment a bit more left out and really depends on the communication. Or how do you bring it to production from this more development level. Any more questions? There's one in the back.
How do you redeploy an adapted application? How does that work?
So the question was how to redeploy an adapted application. The answer for me would be to use Canto here, because you would come up with a new release for your updated application, and then you have another container available in GitHub, and then you send another message to Canto to now use the other container instead of the initially deployed container. And this way you update the container on the vehicle because Canto is taking care of that for you. Yeah.
Is Canto part of the container, so it does an update of itself, or is it outside of the container?
It's outside of the container, so it runs on the host machine. So
kind of bootstrap for the process.
Yeah. So one way is that you have, for instance, Canto already integrated in your Leda layer. That could be one option. So then you don't need to take care of the installation. The other way would be bootstrapping, that you execute the Canto installation script, or there also, I think, is a Debian package available if you more go the Debian route. And once you have Canto available, you can start all the other containers. There's also the argument, for instance, for this cloud connector, if you want to run it natively on your host machine or as a container, which has also its pro and cons. So
Thanks.
There's one question behind you.
So is all of this intended also for safety critical time constraint application on the vehicle or just for infotainment?
So something in between. So like really safety, real-time, time-critical applications, I would say no, at least not to this point. What you could imagine if you go to this stack, I think maybe explains or next one like this, is that when you have your really time-critical safety, ASL, whatever level applications, that you more stay in this deeply embedded world, and then have some way of abstracting out of this world to take the relevant data, which is then maybe not so safety relevant anymore or not so time-critical anymore. For instance, you could say, let's just communicate the aggregate of a value which is changing over the time constantly into the val, because other applications might still be interested in that value, but maybe not so time-critically interested. For instance, in the application with this wiper intensity, of course, it can be highly safety relevant, but if I'm just interested whether the wiper ran for 1 or for 2 hours, it's another story. Yeah.
Okay, because I was imagining, like, for instance, imagine an autonomous vehicle, if I have some perception or something like that, I would really don't want to run that thing on a container, because I will have any time constraint on that.
Yeah, then we're really talking about really low.
Because I can imagine you can still provide some of the metric to the cloud, maybe to improve the AI, but still okay.
Yeah.
Okay, fine.
Okay. Yeah, cool. Any more questions? Yes. Okay, there's one in the front.
Thank you for the good presentation. I understand the relationship between the project in the Eclipse SDV. So if you have some opinion, I'd like to know another Eclipse project for the relationship, this prototyping. For example, another project means Eclipse Chariot or Eclipse eCar in the SDV groups. So do you have any?
So the question is whether we have any connections to the other SDV projects like eCall, Chariot.
Yes, that's right.
It's evolving right now. So for Chariot, I have to be honest, I hadn't a chance to look into the code yet, so I cannot really tell what the connection is, but there might be some overlap, especially looking at velocities. For eCall, I would say it's not yet found, but we're in discussions there. But there are also some...
Graduate.
Yeah, exactly. So, I mean, it's always in the working group, you come up with the different ideas. So this is one approach on how to do this whole stack, and you can still look into doing all these things. For instance, another project which is in Eclipse SDV, it's the Eclipse Some project about to be released by Chariot. And we also in some talks with them about how to put this together, because they are more operating in this really deeply embedded world down here, so this could be one addition there. And this actually brings me to a couple of call of actions I would maybe do to conclude the whole presentation. Because if you're really interested in this kind of topics, if you really would like to get your hands, maybe not dirty, but a bit more hands onto the code, I really welcome you to join our Hack Day on Thursday here at EclipseCon, where you have the opportunity to meet all the different maintainers of these different projects that I talked about. So the idea of this talk was more to give you an idea how to make sense of all these different puzzle pieces, and then you can again talk to the different puzzle pieces. If you like that a lot, there's also the option even for a larger hackathon in the beginning of November in Berlin, where we will have the BCX, which is a whole hackathon dedicated to coming about hack challenges and playing around with these kind of technologies. For instance, having different feeders or different applications to run on top of this kind of data, and also again talk to the teams that develop this, come up with new ideas, and we would really looking forward to seeing some of you there in Berlin at the BCX. And one final thing, that's maybe for where Sebastian can stand up for a second. So, so one thing is about this hardware is, or maybe you explain it yourself, you're even better there.
Yeah, but I also trust you fully. So
thanks.
The point is, so I showed you this nice hardware thing, which is basically Pi compatible. It adds like these interfaces for onboard diagnostic, also has CAN interfaces. That's very cool. It is open hardware, it is Eclipse hardware. The sad thing about it is, at the moment in the whole world, there are like 35 of these existing. And they are lent to people we like, and they have been, you know, carefully handcrafted. So currently we are checking whether we can produce a larger batch of these, because we think they can be very interesting, you know, to other SDV projects to do prototyping in a car when you're ready to move out of a laptop, but not yet ready to move into a production ECU. And to do that, of course, we need money, not your money yet, so relax, stay in the room. But we need to gather some like informal interest, like we need to find out how many people would like to have one of these. And so what we do have here in these nice, it's not a trash bin, trust me, we have here some papers which is called a not order form. That means whatever you fill in there, you're not ordering anything. But if you think this is a cool prototyping platform, you can enter on this sheet of paper, like if this would exist, maybe I could imagine to buy 3 or 5 or 100. Again, it doesn't mean that we will force you to buy 3 or 5 or 100. It just means we will check at the end of EclipseCon how many, you know, papers are in there, how many people think it's a good idea. And then I will go to some people I already know who have money. I will show them this and say, you know, if you just spring up a little bit money up front, I can make like 500 or 1,000 of these. And then we can put it in a web shop, and magically people will come and will buy it. If you think you don't need it, of course, then don't fill it, right? But if you think you would like to have one, fill the non-order form. It doesn't mean anything. We will not force you to buy anything. We will just use it to see if you would like to have this sometime in the future. Yeah. Thank you very much. That's all I wanted to say. Not sure you have further things to add.
What are the approximate costs of it? What's the ballpark? You know, we don't hold you again. Is it unpriced?
So the ballpark numbers are, it's very hard to say right now. I can say below 500. And I guess above 200.
Yeah. Thanks also for putting that together. And with that, maybe see you in Berlin. If you're interested for the hackathon, just contact me, approach me. Otherwise, enjoy the rest of the conference and have a nice day. Bye.